There it goes. Okay, before I do anything, I'm going to go into your journal, and I'm going to go to page 163. I just want you to watch this. I'm at 163 in your journal.
Should we write this down?
Nope, just watch. So, we're going to look at different types of graphs, okay? So, obviously, A is linear. You guys agree? That's linear because it's straight and it's linear positive, okay? Everybody agree with that? Okay. 8, because it's going to level off like this, is logarithmic. That's a log graph, okay? C, we did, remember Skittles? Remember Skittles or Skeeters? That's exponential. Do you see the shape?
Yeah.
D is straight, so it's going to be linear with a negative slope, right? E could be, it could be exponential. It could be. It could also be a square. It could be also some x squared. You just can't see the back side of it. So this one is could be exponential. It could be an x squared, which is a quadratic. We're not quite sure. And that's the same thing on F. And we want to take a look today at our exponentials. Our quadratics might pop up. Yes, Brian.
X squared, would we go back up on the other side?
Yeah, and you just don't see it. Totally, you're so smart, Brian. Totally correct. And the reason we don't want to talk about the backside is because if it's a real life problem, right, we don't really talk about the negatives, right? Yeah, that makes sense. Totally correct on this one too, Brian, that you'd have the negative on the backside, right? Okay, very well done.
So if you made that into an equation, would you have to cancel out the negative?
Yeah, yeah. In fact, this one probably wouldn't be exponential because of the negative, right? That was probably going to be a quadratic, okay? Good question. In any real life problem, we probably won't have the negative. So if we know that, let's go ahead and take a look at our notes. Okay, so today, May 4th, 5/4/22, our objective is to find and graph exponential or logarithmic equations.
Don't be sorry. That's not. Never be sorry.
Okay, and I'll back up and let you write that down. So we're going to find and graph exponential or logarithmic equations, okay? So question 1 and 2, I just want to first just take a look at it. And I just want to find out, kind of guess which one it's going to be. So I'm going to graph it. Am I going too fast? Am I too far ahead of you?
Just give me a quick overview.
I will.
Can you slide it up a little bit?
Yeah, I sure can. There you go. Yeah. Okay, so example 1, and I'll wait for you guys to get caught up. I'm just going to do a scatter plot. I'm going to look at it. When I look at it, it'll have a shape, right? You guys got that? Make sense? We'll do our dots dot. We'll look at it and say, okay, what is this shape? Okay. So, Sophia, how am I doing?
Just give me like
I'm going to. I'm not going to go faster than you, okay? Okay, so let's graph number 1 and get an idea of what it looks like. And I'm going to go, 1, 2, 3, 4, 5, 6, 7, 8, 9, and probably have to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, okay? I'm just going to do a scatter plot, okay? I've got 1 and 81, maybe right about there. 3 and 27, 5 and 9, and 9 and 1. Up 7 and 3. So what do you think? What's it look like? What do you guys think? What's it look like? How about exponential decay? Right?
Grab the notes. Hey,
Grab the notes.
grab the notes.
Have the notes.
The notes.
Right there, Maya.
On the page.
Grab the
Nope.
notes.
I have like 4 glasses too.
Bam.
Let me see your
Bam.
schedule.
Grab it.
I'll airdrop it.
Okay. So it looks to me like it's exponential decay. I'm divide by 3, divide by 3, divide by 3. So I'm taking a third of it each time, right? So it's definitely exponential decay, all right?
So the Japanese?
Yeah, and then we're going to say what type of graph is it? What type? Question mark. That one's definitely exponential decay. You can see it just, it's going a third of it, a third of it, a third of it each time, okay? You okay with that being exponential decay? Can you see how it goes down? Okay, number 2. Let's take a look at number 2. Again, I'm going to graph it first to take a look at what it looks like. I'm just going to go by ones.
Wait, is that a 70?
Is what a 70?
You would 50, 60, and then is that 70 or is that?
Yeah, 10, 20, 30, 40, 50, 60, 70, and then 80s up there. Yeah. Okay. Okay, number 2, again, I'm just going to do a scatter plot. 1, 3, 2, 1, 3, 1, 4, 3, 5, 7. So 5, 1, 2, 3, 4, 5. I did 1, thank you. 3, 1, and 4, 3, thank you. Right there. Thanks, Retta. Retta, me make a mistake? That can't be possible. What the heck? I never make a mistake in 5, 1, 2, 3, 4, 5, 6, 7. Okay, so what do you think? What's it look like?
It looks like a.
Yeah, so it looks like a parabola, which makes it a quadratic. Okay, does that make sense, everybody? It looks like a quadratic, it looks like a parabola, I agree. So we're doing a pretty good job of guessing. Now what we want to do is actually find the equations, okay? And I'll wait for you. So we can graph these, we can guess what it is. And now we want to find the equations, okay? Number 3, pay attention, because you're going to have a question like number 3 on your test on Friday, okay? All right, when you're ready. Valeria, give me thumbs up. I like how you girls take really good notes, so I don't mind being patient. You girls take fabulous notes. If you guys ever want to borrow notes, don't borrow mine. Borrow Valeria's or Sophia's, okay? Notes are right up there.
What?
Notes are right up by Retta.
Oh, thank you. Sorry, I didn't.
Okay, number 3. So what we want to do is find an exponential function. So let me start with this. Y equals AB to the x. Okay, make sure you have that equation. That is our exponential equation. Okay, make sure you have that. Have that. Y equals AB to the x. That's our exponential function. When we did our Skeeters or our Skittles, we use the exact same formula, right? Now, what we need to do is this. We need to find the value of A and the value of B. Since I need to find both of them, I'm going to need 2 points. And I have 2 points. Since I have to find both of them, I need 2 points and I have 2 points. Now every point has some x and y value, right? So I'm just going to use the first point first. Okay, so we'll use the 1, 6 first. I'll plug the 1 in for x and the 6 in for y. So we'll do this. I'll go 6 equals AB to the 1 power, okay? Well, I can't solve for a or b if there's 2 variables, right? But what I'm going to do is this. I'm going to divide by b, and I'll have 6 over b is equal to a. Okay, now all I did is divide by b. That's all I did. Divide divided by b, divided by b, okay? Now, how's that going to help me? Well, I'm going to use the second point. I'll slow down. So the trick for me to do is this. I want to do a substitution. I want to do a substitution over here. You're going to see it in a second. Sophia? We did. Yeah, good for you for remembering that. That'll help, right? That's going to help a lot. So I want to then use my 212. I will need to substitute, but I'm ready to substitute. So let's do the 212 and let that one be my x and that be my y. So let's plug that in. So I'm going to have a 12 equals ab to the 2 power, right? Now, I know what a is. A is 6 over b. So I can put that right there. So I'm going to rewrite this. 12 equals 6 over b times b squared. Okay? I just made a substitution right there. B squared over b, one of these b's will cancel with one of these b's, right? B to b, that'll cancel. So I'll have a 12 equals a 6b.
Wait, is that a times b squared?
That is times because I put it right there, right? Does that make sense, Cassidy? I put it right there. Divide by 6 on both sides. And then I know the value of b is 2. Okay, good. I can now...
So you took away the square, so then there's only one.
Right, because that's the same thing as b times b over b. Does that make sense, Retta? Cancel, right? So then if I know the value of b, I can take the 2 and put it right there and get the value of a, right? So I can go 6 over 2 is the value of a, or the value of a is 3. Okay, now I want to find the answer. I want to find the exponential function, so I'm going to write, instead of y equals ab to the x, I know what a is. A is 3. I know what b is. B is 2, so I'm going to go y equals 3 times 2 to the x. Now, I'm going to say this loudly, so plug your ears. Don't you dare make that a 6. That is not 6 to the x. That is not 6 to the x. What is that? It's 2 to the x. Is that 6 to the x?
Because
Don't multiply those. Don't do that. Okay, got it? See, did I make my point? Okay, good. Whatever it takes, right? Whatever it takes. Don't make that a 6. That's 2 to the x, okay? Good? Turn the page. That's my, yeah, I want to find the exponential function. So this equation, if I graph this equation, these points would be on this equation. If I graphed these points, or this equation would have these points on, okay? Ready to turn the page? Okay. Now, example 3 is the same. Looks so really hard with all of these decimals, but maybe we can do it. Okay, let's see. Same thing. Let's start with y equals a b to the x. Okay, let's just start there. And I've got a x and a y value. So I'm going to go 3.6 for my y value. 3.6 is my y value. A times b to the 2 power, right? So I don't have enough information. So if I solve for a, I'm going to solve for a. Solve for a. And you don't want to solve for b. It's going to be obvious. I'm going to tell you why you don't solve for b, okay? I'd have to take the square root of it, right? I don't want that. How do you take solve for b? I'd have to square root. I don't want to square root, right? So solve for a, it's a lot less messy, okay? So if I solve for a, I would divide by b squared. And so I'd have a is equal to 3.6 over b squared, right? So I need a second equation to substitute into. So again, I'll do my y equals ab to the x. And I'll use my other point, my 5 and my 777.6. I'll put the 776 in for the y value. and I'll put the 5 in for the x value, okay? How am I doing? I need to make a substitution. So instead of writing a, I'm going to write 3.6 over b squared. So instead of writing a, I'll write 3.6 over b squared. So I'll rewrite this, and I'll go 777.6 equals 3.6 over b squared times b to the 5th, right? And 2 of these will cancel with 2 of these, right? You guys agree with that?
Yeah.
So I'll have 777.6 equals 3.6 times b cubed. Divide by 3.6, divide by 3.6, I don't know. That's what calculus are made for. 777.6 divided by 3.6. 216 equals b to the 3rd power. And now you guys tell me, what should I do to solve for b? You cube root it, right? We're going to take a cube root. Nice job, Retta. Cube root, and the cube root of 216 is 6. And if you don't know that, you can just use your calculator. Your calculator will do cube roots. If you go to the math button again, it'll do cube roots, but I know it's 6, right? And then let's rewrite it. So let's rewrite. Rewrite. Y equals ab to the x. We'll rewrite it because now we know what a is. Oh, we don't know what a is. Uh-oh, I forgot that step. Let's find a. I know b, but let's find a. I didn't find it, so I'm going to find it right now. 3.6 divided by 6 squared. Oh, what is that? 1/6, I think. 3.6 divided by 36.1. Yeah, that makes sense. 0.1. So the value of a is 0.1. Now I can rewrite it. I know the value of a. I know the value of b. I'm going to put them both into my equation, right? I'll rewrite this as a y equals a 0.1 times 6 to the x power. Now there's one more question. I don't know if you see it or not in all this mess. But there's one more question, and that is to find f of 4. What does that mean? What does f of 4 mean? Plug it in. So f of 4 means that the x value, f of x, the x value is 4. So we take 4 and we plug it in for x. So f of 4 is like f of 4 is equal to 0.1.
So this part is part of question 3?
Yeah, it's part of question 3. So once you get your equation, we're just going to use your equation, okay? Okay, then 0.1 times 6 to the power of 4 gives me an answer of 129.6. How's that? Okay, now I'm going to stop the recording and I'm going to do a couple of problems on your homework with you, okay?